So today's systems, one of the things that's really setting them apart from in the past is the amount of software that's going into the systems. So more and more systems today are controlled by software. Functionality that was once in hardware is now brought into the system and as software. So you can see a few examples of this. Even a washing machine might have 100,000 lines of code, up to a commercial aircraft, which may have 6 or 7 million lines of code. Even our luxury automobiles, especially the ones that are electric or hybrid type vehicles, have millions of lines of code. And when you think about that, that is causing a lot of challenges in the industry. It's like, how do you test this amount of software and amount of complexity that is being caused there because of the software having to control the mechanical systems and the electrical systems and basically handling all the data that it now needs to process to perform its functions. And there was a study that was done a few years ago that said that basically, and this is an economist, that basically for every 1,000 lines of code, there are about 10 to 20 defects. So if you start doing you can do the math quickly here. If you think about these devices with 100K or millions of lines of code, you're talking about 100,000 defects that are being produced in those devices. But fortunately, most of those defects can be resolved sooner. The sooner they're resolved, the cheaper they are. And most of the time, you're not going to be shipping anything with 100,000 defects, so you're going to find them earlier, but it's important to find as many of those defects earlier because the cost of even a single major defect that would cause a product recall could be millions and millions of dollars. I know there's been a lot of those recalls, product recalls in the news, and we know that any defect getting out there into the market is just going to be a significant impact. So we can go next slide, Cal. So really there's 3 real big challenges here. You have your cost, your complexity, and velocity. So when we look at a lot of the software development and you develop your software, a lot of time you're going to be spending, actually about 60, 80, or 80% of the time, is you're going to be doing rework. So you develop your software, you test it, you find some issues, you're going to go back and redo it. And that rework, of course, so like I said, is just more costly later on in the development cycle. But at the same time, for making a high-quality product, the testing costs are also going up. A lot of times we'd be maybe outsourcing, but labor rates around the world have been increasing, so testing is becoming more and more expensive. So you're not able to do that as effectively. Also, just building the test stations themselves is a huge investment, especially when the systems are becoming more and more complex. It becomes more and more complex to create the test system that will actually be able to test it. And of course, you need to be focusing your testing teams on the right thing. They need to be doing testing of the functionality and validation and verification tests, and not be doing things, manual tasks of maybe submitting defects or manually tracking defects in spreadsheets or documents. That's not the way it can be done now. You need to be able to communicate with the development teams faster. You need to be more agile and react to changes very quickly, not just from the development side, but also from the testing side. The testing team needs to be able to do continuous type delivery and be able to manage the changes that are coming in from the development team